Imagine this, the entire Pacific Northwest suddenly pulsing like a living creature. Volcanoes across Washington, Oregon, and California thumping in sync like they were breathing. It wasn't a movie. It happened. And no one saw it coming. On July 29, 2025, at 3:04 a.m. UTC, a magnitude 8.8 earthquake struck the floor of the Pacific Ocean, just off the Kamchatka Peninsula in eastern Russia. The energy released was equivalent to hundreds of nuclear bombs. Tsunami sirens howled across Japan, echoed along Alaska's coast, and even reached warning systems in Hawaii. But the true shockwave was still coming. Not in the water, not in the sky, but underground. 6 hours later, thousands of miles away, something began to stir beneath America's Cascade volcanic range. Seismographs from Mount Baker in northern Washington to Mount Shasta in northern California picked up a repeating rhythmic pulse. Every 11 minutes, a tiny signal. At first glance, it looked like aftershock noise from the Kamchatka quake, but the consistency, the regularity, that made scientists pause. The pulses were not strong. They wouldn't knock books off shelves or rattle windows, but they came in a pattern, dozens of them, and they came in unison. Volcanoes across an entire region, separated by hundreds of miles, were all responding as if struck by the same invisible force. The Pacific Northwest Seismic Network was the first to flag the anomaly. Seismic stations blinked to life, showing dozens of coordinated pulses across more than a dozen volcanic centers. At first, no one wanted to jump to conclusions. Earth is noisy. Big earthquakes send waves echoing around the planet like sound inside a cathedral. But these weren't echoes. They weren't random. They were too precise. Every 11 minutes, a faint tremor, always in sync, across all major Cascade peaks, like a choir of mountains singing in rhythm. The signals were so uniform that some scientists thought it was a software error. It wasn't. Mount Rainier leads the chorus. Then, just before noon the next day, Mount Rainier changed everything. A new type of seismic activity began beneath its southeastern flank. Long-period tremors, low in frequency, and steady in beat. The type of movement sometimes associated with deep magmatic activity. These weren't dangerous on their own, but they were unmistakably different from what came before. Minutes later, similar tremors appeared under Mount St. Helens, then Mount Hood, then the Three Sisters, almost as if Rainier had called out and the others answered. Emergency alert systems were triggered behind the scenes, not because there was an eruption, there wasn't. Not because there was lava moving upward, there wasn't, but because the data was impossible to ignore. Scientists from the USGS and several top universities met in an emergency briefing. The phenomenon was unlike anything seen before. The signals didn't match harmonic tremor, the kind of seismic activity associated with magma rising, and yet they weren't just background noise either. Dr. Alina Valdez described the pulses as a kind of seismic whisper. It's like the mountain is reacting to something far away, not screaming, not cracking, just responding. Dr. Andrew Forrester added, "You don't get this kind of timing in random geological processes. 11 minutes between pulses, consistently, for hours. That's not a coincidence. That's a signal." Matched filter analysis was used to compare the pulses to decades of seismic records. The results were strange. They didn't look like classic pre-eruption activity. Instead, they resembled deep, slow-slip earthquakes, movements along underground faults that happen so gradually they can't be felt. But these events had never been seen triggering in unison across an entire volcanic arc. Then, data came in from Japan and Russia. Volcanic arcs on the opposite side of the Pacific showed similar low-frequency tremors. Not as many, not as strong, but unmistakably present. It was as if volcanoes around the world had flinched at the same moment. One theory quickly gained traction: planetary resonance. The Kamchatka quake had sent shockwaves not just through the crust, but deep into the Earth's mantle. Like striking a tuning fork, the energy had spread in every direction, finding weak spots and molten zones. And the Cascades, with their complex mixture of magma, water, and faults, had vibrated in harmony. Dr. Tessa Nakamura likened it to pressing a key on a piano and hearing every related string vibrate. The Earth rang, and the volcanoes answered. Other scientists raised even more unsettling questions. What if this kind of event can destabilize fault lines over time? What if a coordinated tremor is not just a response, but a prelude? By the morning of August 1st, the pulses had stopped. The synchronized tremors vanished. The mountains went quiet, but the questions remained. Was this a one-time echo or the beginning of something deeper? In the days that followed, Mount Rainier logged over 1,300 micro-earthquakes. Not damaging, not deadly, but the highest number ever recorded there in such a short period. Mount Shasta registered unusual low-frequency noise. Newberry Caldera's geothermal activity rose just slightly, minor but measurable. Across the region, tiny changes began to appear in satellite thermal scans. GPS sensors showed barely perceptible shifts, the kind of movement that could be meaningless, or the first sign of something waking up. And perhaps the most haunting signal, low-frequency tones captured by hydroacoustic sensors off the Pacific Northwest coast. Vibrations too low to hear, too deep to feel, but real enough to raise red flags. The Cascades are not like other mountains. They are volatile, explosive, and unpredictable stratovolcanoes, sharp, steep, and capable of chaos. When they erupt, they don't ooze, they blow. Mount Rainier, standing tall at over 14,000 feet, is laced with glaciers. An eruption there could melt enough ice to send lahars, rivers of mud and rock, crashing into valleys within minutes. Entire communities lie in the danger zone, with only half an hour to evacuate. Mount St. Helens already showed what it can do in 1980, flattening forests and sending ash around the globe. But few remember that it stirred again in 2004, quietly growing a new lava dome, proof that it never truly sleeps. Mount Hood looms just east of Portland. Its eruptions are smaller but no less dangerous. Ash, lava, and gas could affect over 2 million people. Mount Shasta sits near vital transport corridors. An eruption there could cut off highways, isolate towns, and disrupt national infrastructure. Even lesser-known peaks like Glacier Peak and Mount Adams have violent histories. The entire arc, stretching over 700 miles, is alive. USGS volcanologists reviewed years of data following the July event. They found that while none of the volcanoes showed signs of imminent eruption, they had all reacted in some way. Microquakes, gas releases, shifts in geothermal output. Satellite imagery even caught faint thermal hotspots that hadn't appeared in decades. Most significantly, researchers began seeing the event as part of a new phenomenon, volcanic microresonance. The idea that large-scale tectonic activity can induce synchronized seismic responses in dormant volcanic systems without triggering eruptions but revealing underlying instability. In other words, the mountains are listening. They're connected in ways we don't fully understand. And sometimes, when the Earth is struck hard enough, they speak. Some volcanologists are now re-examining past eruptions, looking for signs of similar global pulses before major events. That next time, we'll see the signs not as coincidences, but as the first tremors of a story unfolding. So what does this all mean for the future? Are the Cascades gearing up for a new cycle? Is a mega eruption coming? No one knows. The current threat level remains low, but that doesn't mean it will stay that way. The 2025 Pulse event showed us that volcanoes we thought were dormant are far more reactive than we assumed. It reminded scientists that Earth isn't a collection of isolated systems. It's a network, one that hums, vibrates, and sometimes roars. If the pulses return, will they bring magma next time? Will another megaquake trigger something bigger? Or did we just witness a harmless planetary sigh? One thing is certain, we're paying closer attention now, because history doesn't always repeat, but it often rhymes, and the Cascades have a way of returning to the spotlight when the world least expects it. The Pacific Northwest isn't just forests, coffee, and tech giants. It sits on one of the most dangerous volcanic arcs in the world, and in July 2025, that arc reminded us it's alive. The mountains hummed, the ground pulsed, and for a brief moment, the Cascades sang together. We may never fully understand what they were saying, but we should never stop listening. If you want more deep dives into the hidden forces shaping our planet, subscribe to Geosphere and let us know in the comments. Do you think this was a warning sign or just Earth clearing its throat? Stay alert, stay curious, and keep watching the ground beneath your feet.